Hello and welcome to the AP Physics channel. Today we're going to take a look at a problem that involves Newton's first law and apparent weight, buoyant force. Let's take a look at the diagram. So we have a block made of iron, density of iron 7860. It has a mass of 2 kilograms and it is placed in 2 kilograms of oil whose density is 916 kilograms meters cubed. Hence, iron is not going to float because it's more dense. The apparent weight of iron is now measured with the top spring scale. So let's start with that question. What is force 1? What is the reading of the spring scale? So the reading of the spring scale, if I were to just draw the free body diagram, I would have force of gravity on iron and then two forces, buoyant force and the spring scale force. Buoyant force, if you remember, is rho of the fluid, G, volume of the object, or part of the object that is submerged. In our case, it's the entire thing. The problem is we don't yet know what that volume of the object is, but we do have all the things that we need to figure it out. If I divide mass by density, that would be the volume of the object. Force of the spring is our question. So then force of the spring from here, force of gravity is mg, and then minus rho of the fluid times g times the volume of the object is mass of the object divided by density of the object. Now, the reason why I wrote it that way is so I can factor out mass and g. Force of the spring will be mg, and then 1 minus rho of the fluid divided by rho of the object. 2 kilograms times 9.8 times 1 minus, and then I have 916 divided by 7860. Grab your calculator, let's compare notes. What did you get? I got 17.3. Now, before we find the reading of the second scale, we need to again draw the free body diagram. Force of gravity, that includes mass of the beaker, mass of the oil, times g. What else do I have? Buoyant force was applied by the oil to the block. Newton's third law reminds us that buoyant force as a reaction will also be applied to the oil, and hence, because the oil is supported by the scale, it's going to be applied right here. I have force buoyant and force gravity coming down, the upward force that equals both of them. That would be the reading of the scale which we are after. This is going to be 3 times 9.8 plus buoyant force, so that's 916 times 2 over 7860, that's the volume, times 9.8. I can factor out 9.8 times 3 plus, that's going to be 1822 over 7860. Grab your calculator, let's compare notes again. So this reading is 31.7 newtons. That is how you solve this question. Thank you for watching.